Here we're going to look at topic 7, example 1, understand absolute value equations. We have 3 examples, A, B, and C, and we're going to go through each one. In A, what is the value of x in 7 equals x, absolute value of x plus 2? So what we want to look at is, in terms of absolute value measures the distance from 0. So since absolute value measures distance, absolute value also always needs to be positive. So in this equation, we have 7 is equal to the absolute value of x plus 2. The first thing you always want to look to do is isolate the absolute value. So just make a little note of that to yourself. You always need to isolate the absolute value first. And then you can kind of go from there. So isolating the absolute value means just pretend you can't do anything with this. All right, we're just going to leave that alone right now and not do anything. So treat it as if it was a variable. It was just an x, pretend the bars weren't even there, and we would subtract 2 from each side. So you get 5 is equal to the absolute value of x. Once the absolute value is isolated, which in this case it is, right? There's nothing else outside of the absolute value on the same side of the equation. It's just the absolute value of x. You can then take that absolute value and you create 2 equations. So this is going to branch off, and you're going to set it equal to the positive and negative versions of whatever's over here. All right, so in this case, you would say x is equal to 5, and there's nothing else you can do with that. And you would say x is equal to negative 5. And those are going to be your solutions. So that 5 and the negative 5 come from that 5. Now again, this measures the distance from 0. So basically what they're saying is that we needed points that were 5 places from 0. And that would be from 5 to 0 and negative 5 to 0. So we have one value that's on the left side of it, one value that's on the right in this case. Just remember that the absolute value measures distance, and the absolute value always needs to be positive. Your solutions, be careful. So this here can be negative, which it is, but this piece here, the absolute value itself, can only be equal to a positive number, and we'll see that that'll come into play in one of the next examples. In part B, what is the value of x in absolute value of 2x minus 3 equals 1? So here, again, we're trying to isolate the absolute value. So we have 2x minus 1 in the absolute, 2x minus 3. We have 2x minus 3 in the absolute value, and that's going to be equal to 1. Now, the absolute value is isolated, right? There's nothing else on the outside of it on the same side. The x isn't isolated, but the absolute value is. So what that means is I can now create my 2 equations. So I'd say 2x minus 3 is equal to 1, and 2x minus 3 is equal to negative 1. So remember, this 1 is going to be equal to the positive and negative versions. All right, so we're taking that 2x minus 3, which was on the inside, and then we want 1 and negative 1. And now you solve these. All right, you have 2 equations, and you would just solve them. So we get 2x is equal to 4, divide by 2, and x will be equal to 2. You should always check that that number works. You should plug it back into the original problem. But in this case, I know that these answers work out, so we're not going to spend the time doing that. Negative 1 plus 3 would be 2. Divide by 2, x would be equal to 1. So we have 2 solutions. We're looking for an absolute value, a distance of 1, and the 2 ways we can get that would be if x is equal to 2 and x is equal to 1. All right, in part C, what is the value of x in 3 times the absolute value of x plus 6 plus 8 equals 5? So here, the absolute value of x plus 6 is not isolated. So what we need to do is we need to get that by itself. Pretend this was just something like 3y plus 8 equals 5, and think about how you would isolate that y. So what I'm going to do is I'm going to subtract 8 from each side. I get 3 absolute value x plus 6 is equal to -3. And here, this is multiplication, so it's 3 times that absolute value. So we're going to divide by 3 to isolate that. And I get the absolute value of x plus 6 is equal to -1. Now we want to be very careful here. The absolute value is isolated. However, remember, absolute value measures distance, and distance has to be positive. Well, this absolute value is equal to a negative number. Can't have that. All right, so absolute value measures distance, and distance is always positive. I'm going to write this again. Measures distance. Distance is always positive. That doesn't mean x is always positive. It means that distance is always positive. So for this one, there is no solution. Now we cannot determine that. All right, we can't determine that there's no solution until we've isolated the absolute value. If you look at example C again, originally it was equal to 5, all right, which seems okay. That doesn't seem like there's a problem. However, once we isolate the absolute value, we get that x plus 6 by itself. We notice that the absolute value is equal to a negative number, which cannot be true, so there is no solution.